Okay, so we are talking about complex numbers today. So just to kind of talk about numbers in general, natural numbers are counting numbers. If you start counting, do you start counting at 0? No. If I'm going to count how many pens I have, I'm not going to be like 0, 1, 2. I'm going to be like 1, 2, 3, 4, 5. Okay, counting numbers start with 1 and go up. Whole numbers are your all natural numbers in 0, so 0 and up. Integers are negative, 0, and positive, and then rational are pretty much everything that's not crazy. So irrational are the crazy ones. Pi, e, imaginary. Okay, decimals that have no pattern and go on forever. Those are irrational. Okay, and I want you to realize natural numbers are also integers, are also rational numbers. Okay, whole numbers are also integers, are also rational numbers. See how they're kind of inside? Yes? Okay. So that's really kind of all we were talking about on that. But note, I equals the square root of negative 1, yes? Okay, so I want you to realize if I have square root of negative 1 and I square both sides, doesn't the square root cancel the squared and I squared equals negative 1? Yes? Okay, if I have I equals square root of negative 1 and I square both sides, then I have I squared equals negative 1 because the square root and the squared cancel each other. So I squared is the same as I times I. So I want you to realize anytime you're multiplying I times I, what does it equal? It equals negative 1. I mean, I knew what you were saying, but yes. Okay. So simplify the following. Anytime we're dealing with imaginary numbers, you want to take your imaginary number out first. Okay, so I am going to make this an I, and I'm going to turn it to positive. So I end up with I square root of 81. Now, what is the square root of 81? 9. So this ends up just being 9I. Okay, because I could rewrite this as 9 squared, because 81 is just 9 squared, square root cancels the squared, so on and so forth. Okay? Any questions with that one? That one should be pretty simple. Okay, but look at number 2. Here, again, we have a negative, so I'm going to move it outside and make it positive. But 27 and x to the 5th are not perfect squares, so I'm going to have remainders. I'm going to kind of do this a different way than I've done in the past. So we're going to break down 27 the same way we have been. 3 goes into 27 9 times. 9 is 3 and 3. So I have a pair of 3's, which is going to go on the outside. I also have that I on the outside, and I have a 3 that's going to be inside. Everybody okay with that so far? All I've done, is break down the 27. Okay, so then I have x to the 5th power. Well, I want you to realize x to the 5th power just means x times x times x times x times x. 5 x's, right? And don't we cancel pairs? Here's a pair, and here's a pair. Don't we get to take pairs out? How many pairs do I get to take out? 2. So that means this is x squared. How many did I have remaining? 1. If I have x to the 5th power, that's 5x's being multiplied, yes? And I take out pairs of 2 because this is a square root. So pair of 2, just like the same concept with these 3 3's, we took out the pair and we left what was left inside. Same concept. There's a pair, so we took out 2 pairs, and that was what was left inside. Okay? So let's look at number 3. Now, is this going to be an imaginary number? No, why not? Yeah, the negative's outside. The only time it's imaginary is when the negative is inside. Okay? So since I don't have a negative inside, I don't need to worry about an I. Okay, but I know 40 is not a perfect square. So 2 times 20, 2 times 10, 2 times 5. Now they're all prime. Now if you struggle with this, guys, make sure you check your work. 2 times 2 times 2 times 5 should equal 40, and it does. Okay, I've seen a lot of people not doing this right. Or you could literally do 40 divide 2. Okay, that's 20 divide 2. Okay, that's 10 divide 2. Okay, that's 5. And you see I put that 2 out every time. Okay, just make sure you're double checking these because I've seen a lot of mistakes with just the factor tree. Okay, so I have a pair of 2 and I have a remainder of 2 and 5. So I'm going to take that 2 out. I also have that negative that's already there, so I'm going to bring that down. And I'm going to put my 2. And I'm going to leave some space. And I have 2 times 5. What does that give me? Okay. Then I have 4 x's. 1, 2, 3, 4. I take out pairs of 2. Well, how many pairs do I have? 2. And I have no remainders. So this is my answer. I know what you meant. I got you. Any questions with that? Okay, so example 4 it's an imaginary number times an imaginary number, right? Okay, you have to take out your imaginary first. So we're going to have I positive. Because I put the I out, it became a positive number on the inside. Well, that just means I times I, which is I squared, square root of 6 times 9. Well, what is 6 times 9? 54. Okay, so I need to break down 54. What goes into 54? 3 27 times. Well, we just broke down 27 up here. So 27 is 3 and 9, 3 and 3. What did I do wrong? This is 2. Sorry, y'all. 2 27 times. My bad. So I know that I can take out a 3. But I also know, what is I squared? -1. So this becomes -1 times 3, square root of 3 and 2, which is 6. So I get -3 root 6. So I want you to realize when you take something out, you're multiplying. Because see how there's no symbol here? That means multiply. Now, if there was a plus or a minus, then I could see when you try to add things. But y'all, there's no plus or minus. Do not put one there. Any questions so far? Okay, so let's look at the back. So here again, what do we need to do first? Take our imaginary numbers out. So it becomes I positive, I positive. What's anything divided by itself? Is 1. So those cancel and give me 1. Do I need to put a 1 there? No, because it doesn't change anything. So then we just end up with 30 divided by 5, because since they have the same house, they can be combined. What's 30 divided by 5? 6. Now, can the square root of 6 be simplified? Well, 6 is 2 and 3. Do either of those match? No, so it cannot be simplified. Therefore, that is my answer. Any questions with that section we just got done with? Okay, so let's look at the next piece. So it says, write the following in standard form, a plus bi. So this is like our imaginary standard form. Okay, that means just the number without an I first and the number with the I second. That's all that means. Okay, don't make it more than it is. So here, I'm going to take out my I first, just like we've done on the stuff we just did. And I'm actually going to separate. So I get -12 over 2 plus something over 2. Well, I square root of 48. Now, I can simplify 48, I think. So let's double check. What goes into 48? 2 and 24. What goes into 24? What goes into 12? And what goes into 2 and 6? I mean, sorry, 6, 2 and 3. So I have a pair of 2s, and a 3 remaining. Well, what do I do with those 2 2s? Huh? Multiply them. What's 2 times 2? I have a 3 remaining. Okay, and what's -12 divided by 2? Now what's 4 divided by 2? I want you to realize this gave us 4i squared to 3 because 2 times 2 and then the square root of 3 left over. And then here was just bringing our I down. Okay? Any questions on that one? Okay, I want y'all to try example 7 while I take attendance.
I have a question.
What's up?
Why do we
Leslie,
the I next to the P8?
type your question because it's my internet's being super spotty and I'm hearing like every other word. Sorry. Okay. I'm glad you figured it out. Awesome. Okay, so we're going to go to example 7. So y'all should have started it. What's the first thing I should have done? Imaginary number. Then what? Separate. And I get 10 over 5 plus I square root of 28 over 5. Okay, well, what does 28 break down to? And what's 14 break down to? So what does this become? Over 5. Now, 10 over 5 simplifies to what? 2. Plus 2i square root of 7 over 5 does not simplify, so that is my answer.
How do you know if it's like going to simplify?
Well, 2 and 5 are both prime, so they're not going to simplify. Now, if it was like 2 over 8, I know they're both even numbers, so I could cut them both in half. Okay, so I'm actually going to do these two, and then I'm going to do one more, okay? So don't get too eager to be done. So I have this one, which is plus, and I want you to realize, is there anything in front of this parentheses? No. Is there anything other than a plus sign in front of this parentheses? Does a plus sign change anything? No. So all I'm doing is combining like terms. What's 5 minus 9? Negative 4. And what's negative 2i plus 3i? There's your answer. You're just combining like terms if it's a plus in front of your parentheses. I mean, you could distribute a positive, but a positive and a positive are still positive, and a positive and a negative are still negative. Okay? So it doesn't change anything. But if you look at the next one, it does change something. Because what's in front of my parentheses? A minus. Now I want you to realize anytime you have a negative touching your parentheses in the front, it means you have to distribute it. Now this one doesn't have anything in front, so this one's fine. 4i plus 7 minus 8i minus negative 9. Well, what does two negatives make? A positive, so this actually ends up being plus 9. So now that I've distributed the negative, what are my like terms? 4i and negative 8i, what does that give me? And 7 plus 9. You want your number without I, and then your number with I, a plus bi. Okay, one more before you move on, and then I'll go back, Victoria, and answer your question. Sorry. Okay, so what if I have multiplying? What do I do here? double distribute. Okay? So I'm going to do 5 times 4, which is what? I want you to realize, sorry, 5 times 4i. Well, that's 20i. 5 times 7 is 35. Negative 2i times 4i. Well, what's negative 2 times 4? And then I times I is I squared. Negative 2i times 7 is negative 14i. Now, what are my like terms here? 20i and negative 14i. What do those two give me together? Positive 6i. So I know that's part of my answer is the positive 6i. But this is I squared, so it's not like those. And this is a whole number. But what does I squared equal? So this ends up being 35 minus 8 times negative 1, because that's 8 times I squared. Well, what's negative 8 times negative 1? Positive 8. What's 35 plus 8? So I just wanted to show you what happens when you have that I times I. Okay?